Good afternoon. I, Darren Mujib, from the Department of Computer Science and IT, would like to welcome you all to today's Tech Talk session on technical nuances of real-time databases in the industry, organized by the School of Engineering and IT. I would like to extend a warm welcome to our speaker for this session, Mr. Waqas Khalid, Engineering Manager at Noon Ecommerce. Mr. Waqas is a technology graduate with an expertise in building microservice architectures in Python, Django, Spring Boot, and React. He has an experience of over 7 years in building and managing services in the field of logistics and supply chain. Mr. Khalid has served senior managerial positions in Fetchr, Architect, and Caremerger prior to his appointment at Noon Ecommerce. We would like to express our appreciation to Mr. Waqas for taking the time to share his industrial knowledge and experiences with Mahidubai's faculty and students. Without any further delay, I would like to invite Professor Zahiruddin Ahmed to give us a brief idea on today's topic of discussion. Over to you, sir.
A very good afternoon to all and a very warm welcome to all the participants. Database management system or database. We have been hearing this term from past 3 decades. Now we have reached to the level where we record what we do in our daily life. In fact, what we eat, we record today. The photographs that we take, we record today. So the data has become part of our life. And the importance of the database management system has become so crucial that it is part of every application into the world of information technology. The importance of database management system has been there from the beginning. What we see is that the traditional way of database management system has moved to an unconventional, in a very different set of models and methodologies. It's been very long into academics that we have learned about the concepts of database management system, from its architecture to an organization. Now we have with us Mr. Khalid, who is going to share his expertise towards the implementation and the real-time experience of how database management system is organized from the industry perspective. So I would like to thank as well as welcome Mr. Khalid, to give his insight and information about present database management system and the technologies which are supporting database management system from the industry perspective. May I request all of you to welcome Mr. Khalid. Over to you, sir.
Good afternoon and welcome everybody to this session. First of all, I would like to thank Darren and Sir Zahir for giving a brief knowledge about myself and also about the topic that we are going to discuss today. And thank you so much for taking this initiative and arranging this talk, because this is a topic that I have seen in the industry, that students are not that much connected how things are being used, especially the database being used in the industry, and what are the standards that we are following over there. So what I will try my best to today is to fill that gaps that students do not have knowledge about, and it will also help you during your interviews as well. Like when you are giving interviews, there are certain questions that are being asked about the databases, and you would also be able to answer those questions as well. I have created a very small presentation. I will like to share my screen with you guys. Please let me know when you can see my screen. Can you guys see my screen?
Yes, sir, you can. We can see.
All right. Okay. All right. So this is a small presentation I have created. So I will start with the presentation as introduced by Darren. It's technical nuances of real-time database in industry. So first of all, like before going into the details, like as you know, there are a lot of different database management systems that are available in the market and that are being used in the industry as well. So as you can see the list that I have given, these are few of the famous one that is being used in the industry. So relational database, as you can see, it is pointed and bold because relational database is the one that we are going to talk about today, and our topic will be concise on this topic. Apart from that, there are other database management systems that are available in the industry, like hierarchical database, network database, object-oriented, and one of the famous one that you have heard about, like NoSQL, like MongoDB, and all that, which does not have a proper structure like a document DB. But we won't be able to cover those. So today we will focus on the relational databases. Okay, so before going into like detail of the relational database, like there is one concept that is really important to understand in database, that is a transaction. So what is a transaction? So in the database term, transaction is something that is defined as a group of tasks, and a single task is the minimum processing unit, which can be divided further. Okay. In database, the most important thing that happens is either the full transaction is posted on the database or it is not. Like there is no middle ground in between. So for example, like one of the most important like information that we can give you is like you are transferring your money from your bank account to your friend's bank account. So there are set of operations that happens over there during that transaction. So what is the first thing that will happen? So the first thing that will happen is they're going to go over there and read your account balance. So if you have the balance and it is a efficient balance, like take example, you are transferring a certain amount and there is an available amount in your account, it will go to the next step, then deduct the amount from your account. Then what it will do, it will write that updated amount, the remaining amount on the database. Then what will forward this transaction to another bank. Take example, we are talking about the same bank. Then the same bank, what will do, it will read your friend's bank account, add the amount and write it over there. So all these things, like 6 steps, is actually one database transaction. So how it works in terms of databases. So in the database transaction management system, first of all, there is a concept of commit and rollback. So when you start any transaction in the database, what it does is it gives you a sort of a clone. Okay, this is the point where you have initiated all your transactions in one go. So it's a, you can say, all type of database access operation which are held between beginning and ending of transaction are considered as single logical transaction in database management system. So what I was explaining in the previous, like from reading your bank account to the last point, writing the updated balance to this account is one transaction. So during this transaction, database is inconsistent. Okay. So you can take example, it's a database and there is a clone that is created from that. And then you updated the balance, like it is written over there that you have updated the balance of the account. Now, once you have updated the balance of the account, if anybody else trying to read that, it is not consistent with the one that you are doing at that current moment. Because take example, 1200 is the balance in your account and you have deducted to 1000 and still your transaction is going on. At that moment, the actual DB is showing 1200. Whereas during your transaction, there is an inconsistent database that shows that your new amount is 200. So that is the inconsistency period unless the transaction is posted on the database. So I will explain how it is there. So this is the database in the consistent state. As soon as you put your ATM card in the bank and you started your transaction, so at this moment, you will have the same data that is currently in the database system, like what is being shown to all the other system or all the other who are seeing this transaction. So as soon as you started doing, so temporarily during that period, unless you have posted that, the database will be inconsistent state. So all this state, like starting and ending, between that will be the work that you will be doing on the database. It can be anything like inserting, updating, or reading. And once the database you have posted and ended the transaction, all the things that you have done will be posted over there. Now, there is one thing that there is a little gap between the knowledge is when you have started a thing, what you are doing. First, you are reading a database. That is one type of action that you have done, like dating your own account. The next step that you have done is updated the account balance. So that is the second thing happen. And then you have read the account of your friends and then updated your friend's account balance. So there are two different actions that happen. What happens in the database, like in the database transaction management system, at the end, when your transaction ended, at that moment, everything will be updated on the database. Don't think like when you are writing a code and you have written update on the DB and update on the DB, like updated the amount, the first step. Okay, let me go back. So when you have written, write the remaining balance to your account. Take example, you have 30 line of code and you have updated the balance of that account. That will not happen on the database. So all these things happen at the end of the transaction, not in between. So in between, it is showing from your coding perspective or database perspective that it is being posted, but actually it is not. So how it happens, like this is an example that I'm going to show. So first of all, start transaction. So start transaction is a sort of a code, like it's a pseudo code. Don't go into details of this. So start transaction is your code, whatever connector that you are using of your language, that your Python or Java. What it does is it creates a new connection with the database at this moment. And this transaction is actually sort of a single transaction. Now, after that, as you can see, there is a try catch and rollback. So I have written over there, M is equal to your account and F is equal to friend's account. So if you go from the first one, M is equal to R. So it has read your account and pick the balance into M. Then M is equal to M minus 100. And then the next line is writing that M in the code. If you see from the sequential point of view of the coding, you would consider that it is actually written over there on the database, but no, it is not. When it is going to be written, you will do the other processes. Once you have done the complete processes and you do commit, at that moment, what happens is all the actions that you have taken, it is created as a separate set of transaction, like separate set of action, and they are posted in one go in the database. And this is how it works. And in any moment during this transaction, if any exception happens, take example, you are going through it, you try to write down and take example, you read the database, it shows 200, then you try to write it down, some exception happen. It can be, take example, a connection thing, like the connection is broken, anything else can happen. Or take example, there is another, when you acquire a lock, when you are writing something on a certain row, there is a lock that happens. If there is another there is another transaction that is also happening. How it can happen? I have given my ATM card to my brother and asked him, okay, go and take the money from it. He went over there in the ATM card. During that moment, I have also opened my internet banking and I tried to transfer a money. So take example, at the same moment, both of us try to transfer a money. He is trying to deduct a money 1000 and there is 1200 balance in my account. And on the same time, I'm from my own account, try to transfer 1000 to another friend's account. So when we both are trying to do things on the same time, what will happen? So there is a concept of locking in the database. Whenever you try to update any row or anything in the database, there is a lock, that explicit lock you can take. There are different type of locks. That's a whole another topic to discuss. But what it does is it is locking a certain row, and now you are not able to do any action on it. People usually have a sort of knowledge that you can only have a lock for only writing, but it's actually you can also have a lock on reading as well. So there are certain, MySQL has its own syntax of doing it, Postgres has its own, and then Oracle have its own set of actions. But the major concept is whenever you are trying to do it, there is a lock that happens on that row. And after that, whoever gets that lock first would be able to complete the transaction and other one would be failed. So in this, once if everything gets successful and it comes on this line of commit, if it runs this code, after that, all the changes that you have done over here, like writing two different balances on the database, will be posted. So these are the different type of states that we see in the database. What is active state? When a transaction enters into active state when the execution process begins. Like during this state, read or write operation can be performed. So as soon as you start a transaction, if I go back to my old slide, the start transaction, after that, it becomes an active state. Now, what is partially committed? A transaction goes into partially committed state after the end of transaction. So when we have write WM, like update the balance of my account, at this moment, this is partially committed. So what is the meaning of partially committed? So database has its own concept of keeping the record of all the changes that you're trying to make on the database. So this is partially committed. Partially committed, it's actually recorded. Okay, this is what I'm going to do, but it is not recorded in your original database. So it is in the middle state, like this state. In this state, any transaction that you are doing on the database is partially committed. So this writing is partially committed state. So committed state, when the transaction is committed to the state, it has already completed its execution successfully. Moreover, all of changes are recorded to database permanently. So this is the committed state. When I explicitly told, okay, committed. So as soon as I write a commit over there, what it will happen is all the changes that I have done, partially committed changes, will be posted on the database. And if there is a possibility when you are writing a commit over here, you were not able to post it on the database. This can also happen. At that moment, an exception will happen and the rollback will happen on the database. So what is a failed? A transaction considered fail when any of the check fails or if the transaction is aborted when it is in an active state. As I've told you, like any exception that happens during the transaction, one transaction, single transaction of database, all the changes that you have done during that moment will be reverted. And then terminated state when reaches the terminated when the certain transaction which are leaving the system cannot be restarted. So how can it be explained in the begin transaction? So as soon as you go, you have said like begin the transaction, database will give you a one transaction to you. Now you become in the active state. Now in the active state, you can directly go to abort and then failed and terminated. Like this is the final stage. Terminated is the final stage. So that you can say is the end of any transaction. But if you have done a certain like sort of actions on the database, what will happen is it will be started partially committing in the database over here. And once you have done all the partially committed things are done, then in one go when I written in the code like this one committed, what will happen is this will commit it on the database. And if the commit is successful, after that the whole thing will be terminated and it will be posted on your database that is being viewed by everyone. So how to explain like in a very simple term, like if you want to see in a real time, this thing is happening so fast that people don't even know like all these steps are happening. So if, for example, if I want to see this happening in actual world, what you can do is you can come over here, you start a transaction with the database, and after that put a sleep. Like in programming, you can put a thread on the sleep. You put a sleep for 10 seconds and go and check in the database if the M is updated or not. If you check the database from your any database manager like MySQL, SQL Pro, or any tool that you're using to connect with DB or command line, you will not see that this transaction has happened. You will see that the balance is still 1200. So what is the terminated? Terminated state, at the time of terminated state, all the changes you have done is actually posted on the database, and that database will be viewed by everyone. So if to conclude this whole transaction thing, any sort of thing that you have started in the database, it take example, it's in a very layman term, if I try to explain this particular thing. I have started a transaction. What it will do, it will create a clone of database for me and say, okay, play with it. So I have created this clone on one side. And now what I'm trying to do is I'm starting playing with it. I put a thing over there that will be updated, but it is being updated on that clone. It is not being updated on the actual database. So that clone, I have inserted something, I have updated something, etc., etc. Once I have committed, what it will do is it will try to put all the things, uh, all the changes that I have done on the database on the main database. So what it will do, it will try to make it same. So it's like in database term, whenever any transaction happens, there is a bin log concept that records, okay, what is the change that happened, like read, write, and everything. So what it does is, at that moment, when you click on committed, explicitly say, okay, committed, it reads all the bin logs, which has all the changes that you have made, and try to do it on the main database. And if it is successful, that is the state when it is terminated. Okay, so now what are ACID properties? So how this whole thing is being managed? So there is one beauty that I have seen about the database and the ACID property that a lot of people don't have knowledge about, but it is a very powerful tool in creating all sort of applications that are very time sensitive, where there are certain race conditions. I will give you one example. Like what race conditions, somebody try to mark order, like in Noon, somebody try to create an order, and then there are so many transactions at one moment, people are trying to create order. We have a YFS sale, and during that, like there is a load on the system, obviously a lot of people are ordering, and that moment, what is happening, there are so many transactions being posted on the database, and at that moment, how database is handling it, these are the ACID properties that handles most of the complexity, and we don't need to handle those. Database does it for ourselves. So what are ACID properties? So ACID properties are used for maintaining the integrity of database during transaction processing. So it stands for atomicity, consistency, isolation, and durability. So start with atomicity. A transaction is a single unit of operation. You either execute it entirely or do not execute it at all. There cannot be a partial execution. So the example I was giving you, changing your database, like changing your balance and transferring it to your friend's account is the sort of a concept of atomicity. So it is one, either the whole thing will happen or not or not the complete thing. It is not like if I go back over here, third line is executed, system gives you exception on the fourth line where it is saying f is equal to r of f. Or take example, the next line, f is equal to f of 1,000. If you take concept of programming, what you will consider, like this particular line is already executed, that means it is already completed. But in database term, no, it is not. So in database term, it is completed when all the things are completed. So that is the definition of atomicity. Now consistency. Once the transaction is executed, it should move from one consistent state to another. Like I have during that transaction, I was telling you that once you started a transaction, what it does is it creates a clone for you. So that clone is one sort of consistent state for you. You started posting things onto it. It became inconsistent. Now you have to post it on the original database. So once it is posted on the original database, then it becomes a new consistent state. So that is what database is also handling. Isolation. Transaction should be executed in isolation from other transaction, no lock. During concurrent execution, intermediate transaction unit from simultaneously executed transaction should not be available to each other. So it's the same example that I was giving you. I was trying to transfer the money from my internet banking to my friend's account, whereas my brother was trying to get the money from the ATM. At that moment, if we are trying to do this transaction at the same milli or microsecond, like that fast, this, you can say the race condition could be, at that moment, database put a lock over there. So whoever acquires the lock first would be able to complete the transaction, and other person will get an error that you cannot do it. So that is the beauty of it. If you try to handle this in coding, you would never be able to do it by yourself. Like take example, what is the best way to handle this condition in the coding? I write a code, and in the code, what I do is somebody says, okay, remove 1,000 from this account. So first, what is the first thing logically you will try to do? You will try to check what is the current balance of this account. So you went into database, check the current balance, and it showed you 1,200. And then you put a check, okay, 1,200 is the balance. Okay, no problem. Balance is enough for me to make this operation. So I will go into the next line. But if you consider the same way, another person is also doing the same transaction on the same account, they both went through that piece of code which was reading from the database at the same time. There is a possibility. And they go through the same line. Now, both of them will get success. Like I was trying to move the money to my friend's account. I went through the line. It saw 1,200 is the balance. Okay, it's good to go. Whereas on the same time, like a microsecond, my brother tried to remove a money from the bank. He will also get the success because 1,200 is the balance. But after that, one of the transaction can be executed. So if we totally rely on coding, what will happen? Both of them will get a cash, and then the loss will go to the bank. So this cannot happen. So that is the beauty of database. It handles this part of thing. So either it delays the other one, put them into a lock condition where they are trying to acquire a lock. Please give me a lock of this certain row. And if they don't get a lock, they won't be able to complete the transaction. And like I have mentioned, whoever gets the lock first would be able to complete the transaction. Locking is another complex, like there are different type of locks, but it's just, you can consider, okay, I went first, I pick up the thing, so it is mine. First come, first serve sort of thing. Now the last thing, after successful completion of a transaction, the changes in the database should be persisted, and even in the case of system failure. Yeah, that. So no matter like these database management system are running on some systems as well. So what it has to do, it has to be durable. Like even during a transaction, like 2 or 3 actions has happened on the database, and suddenly like system went down. The server on which the database was running, it went down, something happened, it got corrupted. So what it does is it keeps the durability perspective as well. So these are very important. Like you can go on the internet and check the more details about it. And these are a very important thing that are being used in the industry. And whenever you are trying to work in a sort of environment where you can imagine the load is high, I will give you example. Careem is one of the thing. Like when I have requested a Careem. Okay, I said, okay, pick me up from my apartment and drop me on the JLT. So I have posted it. What happens is it went to Careem system, and Careem systems try to look for, okay, which are the drivers available in this area, and they send them all the requests. All of them request to start this. One of them will accept. There is a huge possibility that multiple driver click on accept button at the same time. So what will happen? All those requests comes to backend. So whoever would be able to get the lock first, they will be able to accept it, and the other will be rejected. So these things are very hard to handle by code. This can only be handled by database itself. Okay. So this is a very important topic that I have seen. Like I would tell you, when I was making my own final year project, I have struggled a lot with this. At that moment, I did not know the concept of idempotency. So I think this is a very, very important concept that you will learn, and you can use this during your final year project. It will help you to design your database in a way, in a certain way. Second, it will also help you to work in a sort of environment where there is a lot of real-time things are happening, and there is a possibility that you get more than one call for the same thing. So this concept helps you to handle those situations. Okay. So an operation is idempotent if it produces the same result when called over and over. An identical request should return an identical result when done twice, 2000 or 2 million times. Okay. Just to elaborate a little bit, I have one example. There is a common practice in the integration of payment gateway that you need to send a unique or a dependency key while creating a request to charge the credit card. Now, if I am a customer, I go over there, I click on a certain button twice, or due to some system, I I started the transaction. If I am being charged 2 times, I will not be happy about this situation. Whereas in computer science, these things happen. You get multiple calls of the same thing. So how to handle this? So what it says is that first you create your like I took this example from Stripe, so I will give you example of Stripe. Stripe is also used for integrating payment gateway with you. So I have integrated with Stripe. I put a credit card and I started the transaction. So what will happen? You know, in HTTP, we keep alive our transaction with the server. So I started a transaction, customer gave the credit card number, everything, and press OK. Once it press OK, so the first thing I do, I started the transaction. I said, OK, this is a credit card details. Give me the token. The token comes back, and then I say, OK, get this much money from it. But while I was having a transaction with this third party like Stripe, my connection broke with that server. Now my connection is broke. I have sent the request to external system already. That system might have started the transaction already with the bank and successfully got the money. But because my connection is broken, I won't be able to get the success result. It is just like you have sent a request from your computer to a server, okay, and said, okay, create this, take example, order. You are an e-commerce company. You said, okay, create this order. You sent to it, and suddenly your Wi-Fi is disconnected. Once your Wi-Fi is disconnected, you won't be able to get a response that it is completed successfully. So during that sort of situation, it is a sort of concept where you need to have your unique key that can be used to fetch the information from here. So of how this particular concept will happen, I create a unique key ABCD1234, and I started a transaction with Stripe. I said, okay, this is my key, and start a transaction. So it started the transaction, it started posting, it started to get the information from the credit card or bank system, and it got successful. My Wi-Fi is disconnected. I wasn't able to get the response. So what will happen? My Wi-Fi is back. I refresh my page. Now in my database, I already have this ABC123. I send the same request. Okay, charge this account with the same every information, ABC123 credit card. When the Stripe system will get this request, what they will see, okay, is there any transaction that is in our system with the same key? If there is not, they will initiate a new thing. If there is, what they will do, they will fetch the result of that thing and return it to you. This way, you will never be able to have a two transaction. Another thing that I can explain, like you have sent two simultaneously requests to Stripe server. Okay. Now Stripe server must have a certain sort of thing in their database as well. So what they will try to do is they will try to create this key in their database. So if you have sent two keys on the same time, there is a unique constraint on the database on their side, which will accept one of them and fail the other one. So this is the integrity constraint that we have in the database. And that is one of the beauty of handling all these race condition and the sort of transaction where duplicates are coming. So I will give you example of like this is a small database I've created. It's not a Stripe database. Just from my perspective, I have created it. Payment request. So what you will do. So somebody asks you like you have to create this system. How will you come up with the design? So that is really important. So first is like ID, it's a primary key auto incremented. If anybody has confusion on this, like this is a normal concept that is being used, and it is also, you can see over here, primary key. Then you have an ID client. So ID client is like anybody who is creating a new account with Stripe to integrate with them, they give you a certain ID. So that is ID client. What is reference number? Reference number is that unique number that you are sending into Stripe to create your transaction. Then ID, currency, status, amount, updated at and created at. But if you see an interesting concept that we have created in the last line, that is a unique key. So I have said over there that ID client and reference number are unique. Now, what will happen in the database? You have put all the checks. This reference number exists in the database. It does not exist. Two of the transaction came at the same time, went through the database. They tried to check if this reference number of this client exists in the database. At that moment, nothing exists in the database. Both of them passes that thing and then start doing all the other actions on the database. But when they are inserting in this table, one of the transaction will fail. Why? Because whichever was able to put this transaction on the database, as soon as they put it, ID client and reference number, it will be created in the database like a transaction 1 or 2. Transaction 1 was able to create this and insert it in the database. The whole transaction got successful. Transaction 2 passes all the checks as well because they came on the both on the same time. But as soon as it tries to insert into payment request and put ID client and reference number, what it will do? It will raise the error of integrity that is being handled by database itself. Like you don't need to do it. The database will do it. So all you need to do is you catch your exception if the database exception is coming in your code, and then just revert it. Like I roll back all the things that happened for this transaction. And this is how we able it. What is another concept is somebody is creating an order in Noon system. Like there are a lot of places like you're registering your account. If you're registering your account, there is one unique key that you are using. Take example, email is that unique key. Or if you are creating any account in government services, Emirates ID is your unique key. Once you're putting it and clicking on submit button, if you submit 2-3 times from the front end, there is a possibility that front end send 2-3 calls with the same payload to the backend. Now it's a register thing. You have sent the same payload. What should system do? System should give you the same response for all 3 of them. Because you have a unique key. On the basis of that unique key, other 2 calls can be rejected, or when it fails because of integrity constraint, what you can do is you can go into database again, fetch the information and return it back the same response. So that is a concept of idempotency. Now, the most concept that people are confused about, like are not confused about, they know very brief knowledge about what is index, but they don't know how it is being worked in the database and what are advantages and disadvantages of it. So the first thing is like indexing is just like a data structure technique. Like all the people like who have taken data structure and algorithm subject, they should know like we have a different type of techniques like hash table, B tree. So these are being used in the database itself to retrieve the information quickly. So an index is a small table having 2 columns. So the first column comprises of like a copy of a primary key, whichever, and then the candidate key of the table. Like I will explain you in the table how it is being done. The second column contains a set of pointer for holding the address of the disk block where the specific key value stored. If you know about the hard disk, how things are being saved over there, it's just a one address and the system puts the information over there on the one address. Even in the programming, if you create an array, what it does is it has a pointer to the first location. and then it has a consistent, like the next location would be equal to the size of whatever you are using. If you are using integer, it will be like 8 bytes and something like that. But at the end of the day, it is all addresses which are being stored in the database. And if you have a pointer to an address, you can fetch the information right away. This is how the like the memory system and all the memory system works. So how it is working, like I will give you a type of indexes. So we have a primary indexing, we have clustering and secondary. I'm mostly giving you knowledge about the primary one, and the other one has the same concept. You can read about it, but I will be focusing on this primary one. So primary has two types, dense and sparse. Okay. So what is a primary index? In primary index, it's an order file, which is a fixed length size with two fields. Okay, it is a fixed length. Why it is a fixed length? It is equal to the size of the table for which you have created that index. The first field is the same as primary key. So whatever primary key that you have used, usually we use auto incremented ID, integer or big int or whatever. So that will be, you can say, the primary key. And the second field is pointed to the specific data block where the information is stored. So you can, I will give you example in the table. In the primary index, there is always one-to-one relationship between the entries in the index table. So there are two types, like I have mentioned, dense index and the sparse index. So this is the example. As you can see, 10, 20, 30, 40, 50, 60, 70, 80. What are these? These you can say are primary keys of a table. So there is another table that gets created on the basis of index, like a separate table created in the database, which keeps the primary key, and the second column keeps the address where the whole row, the information of that row is stored at. So if I go back in this table, so ID payment request will be the one that will be stored on the first column, and all this information, what is ID client, ID reference, that will be stored in one of the address in the memory. And this certain thing, this pointer is pointing out to that memory which contains this information. So the only difference between a dense index and the sparse index is there. In the sparse index, you are not keeping the address of all the locations. You are just keeping like 10, 20, 30. And from there, you know, okay, if I have to go to 11, what do I need to do? That is just a memory efficient thing. So I will explain that. Like if you see this, it's appear only for some of the values. So as you can see, 10 is there, 30 is there, 70 is there. If you get a primary key 20 and you want to get information about 20, so what you will do, you go into the database. It's just a hash tree algorithm. You go into the database, you check, okay, 10 is there. You go to next one, 20. It says, okay, 20 is not there. The next pointer is 30. Once you know 30 is greater than 20, you will say, okay, I need to use the 10 one. You go to the address of 10 and then sequentially check the database one by one. And then you reach a point where you will have information of 20 available over here. So this is the concept of sparse index. Okay. Now, as it is mentioned, why indexing is being used, like to fetch the information very quickly from the database. So there is always a question comes, okay, if it is helping us to get the information very quickly from the database, why not create index on all the columns so that with whatever query that we are making on the database, we will get the information quickly. But there are pros and cons of indexing as well. Why? So if I ask, like this is a most common question being asked in the interviews as well, like, okay, how index are created? So people don't have knowledge about there is a separate table that gets created and how it is being stored. So this is the example that you should know, like how index are created in the database. Second thing is that if it is like there are so many advantages of indexing that you can get information very quickly, why not use this on all the column? So what it do, like if I ask you any question, like anybody who has learned about the hash map in depth, they know that once you delete a certain key from your hash table, the whole hash tree has to rearrange itself. and that is a sort of costly thing. So that is what the disadvantages of indexing as well. I will go in detail in that, but first I will tell you the advantages. If I'm reading a file and I need to read the complete file to fetch information that is in between a certain point in my file, it's quite a heavy process for input output operation. Why? Because the system would have to put all the information, move it from the hard disk to RAM in order to fetch this information. But so for that, there is a lot of processing that is they have to read one by one all the addresses and eventually come to a point where you can have the actual information that is stored that you're looking for. Like I put 20 and it is not stored in an index way. What I will do, I will open a file that keeps the information of that table and sequentially start reading it. But as soon as I'm reading it, I'm loading that file into RAM and doing all the operation, which is very costly input output operation. So with the help of indexing, you right away know, okay, this certain information is either at this exact address of the memory or within like 10 or 15 address of the memory, which is like, if you consider like the powers that we are getting right now in the databases and the RAM, it is really easy for database to fetch that information quickly. So that reduces input output operation. That secondly, obviously, like if you have a pointer to the addresses, it is really easy to retrieve the information. But what are the disadvantages? To perform the indexing on the database, as I have mentioned, like there is a primary key on the table with the unique value. So like it's a sort of thing you always need to create this primary key in order to create it. So it's just a requirement, not I would say a disadvantage, but obviously like you would have to create a primary key on the table to get this unique value. So that is the first thing you would have to do. Other thing is it decreases the performance in insert, delete, or update. Why is that? As soon as you insert anything, what will database do? So first thing, database will insert this in the table. The next thing it has to do is it has to go and rearrange the whole tree of index, because there is a possibility that you have created an index on string. Okay, like if you have created a index on auto incremented ID, database always knows that if a new row is being inserted in the database, it is easy, it will always be greater than the current highest value that we have in the database. But if you have created an index on name, so database does not know what name is going to come and what is like the sequence of it. So what it has to do, it will get that key and try to put it in that index table. So that index table will have to be updated. So this is a sort of thing that is costly. Delete has the same impact. If you're deleting a row, you are actually deleting one of the key from the index table as well. So it has to do rearranging as well. Same with the update. If update has happened on the index column, then the system would have to update the index tree again. But it is not like, if you think about from industry perspective, it is not like you have created an index on 2, 3 column and it started to go slow. No, it is not that. But it is like when you go into industry, there is a possibility you will have 20 or around 10, 15, 20 columns in the table. And there are certain columns that are being used for indexing. So over there, you will have to be intelligent and see, okay, if I insert an index on this table, like is it insertion friendly or read friendly? So these are the questions we ask from ourselves while creating all these index. And this is a question you need to ask yourself as well when you are selecting a database as well. Like there is a very common thing. We have Oracle, we have Postgres, we have MySQL. Like what are the disadvantages or advantages of each database? What are the techniques that are being used in the background for all these databases? Like they have all their own structuring. Now there are two like very well known open source databases. One is Postgres, other is MySQL. Okay, you need to go over there and need to read about it. Why not? Like if you putting anything related to database on your CV and saying like I have used Postgres and MySQL, the first question that you're going to get from the interviewer is, why you have used MySQL in this project and Postgres in this project. Like this is the answer like usually the candidate does not have. So you need to go over there, and there are advantages. Like MySQL is very read friendly. Okay, my Postgres is write friendly. So it depends upon your ecosystem, like the system that you are building. Do you need to use a MySQL in this or Postgres? That is solely depend upon your business case, and you would be the right judge of it. But you, when interviewer is asking, you should tell them, okay, this is the reason why I have used Postgres, and this is the reason why I have used MySQL or Oracle. So yeah, that is a little information about indexing, and I think yeah, that is all from my side. If you have any question, feel free to ask me. Don't be shy. Like I'm very open. Like any question that you have related to database or anything that have come into your mind related to this topic, you can ask me. Over to you, Sir Zahir, if you can help me in this.
Thank you very much, Mr. Khalid. It's a wonderful talk and brief introduction that you have covered in database management system regarding the transactions and their state, the locking mechanism that you have explained us, and most importantly, the asset properties, right? And I'm sure the students must have not heard about idempotency, okay, which is really a new concept, and the advantages and disadvantages of indexes as well, right? That's it. So it's really a good talk and informative. Now we are open to take some questions, like from the audience. Okay.
Okay.
As we have already received one question from one of the participants that they wanted to ask you. What is the next generation of database management system is going to look like?
Okay, like this is a very tricky question when it comes. Like when people talk about like SQL database and NoSQL, like it depends on your use as well. I would not say like SQL will be a sort of thing that is outdated in that term. Like it's a sort of thing that is improving. The only thing that we are getting is like they are improving their way of making indexes because it's all about the computation that we are getting. Secondly, if you go back in the time, we had a constraint of memory as well. But now we are moving into a direction where memory is not a problem. People don't care about how much hard disk you are going to use because it is very cheap and available over there. But there are a lot of constraints that when they were designing a database system, they were keeping this thing in mind that we have a limited space and we have to do things according to that. But now that has changed drastically. Secondly, there are certain things people were having in their mind related to RAM. Like any input output operation that you are doing, they will be moved to RAM, and then the things are being done. We had magnetic disks before. Now the things have moved to like SSDs. Now we have faster input output operations. So all these things, what people are trying to do is people are trying to improve the current databases around that. Secondly, the concept, what I can see in the future is the evolution of NoSQL databases. Because in SQL database, it is really hard constraint for you to make the system in a particular way. You have to create foreign keys. You have to define the table. What are the columns over there? But now that is also changing. Right now, for one certain thing, like take example, like I want to store information about myself, and I say, okay, do I wear a watch? Take example, keeping it as a one column in the database, I would have to create a column, but that column is not being used by a lot of people. So why not keep this information in a NoSQL way where you can feed this information? There is one thing you should learn also as well. Now, Postgres SQL and after 5.7 MySQL version, there is a JSON field that is also introduced in the in relational databases as well. So now what you can do, you can create one JSON field and put all the extra information over there. And it's a very nice trick, I would say, from the perspective of relational databases. Now if you're saying this is information that is not critical to my database structure, what you can do is you can create a JSON field and put all the attributes over there extra. So this is the direction where people are moving into. Secondly, all our APIs and all those things are mostly like JSON friendly. So that I would say is the future where we are moving.
The next question is SQL going to be outdated now?
I have answered in the first question as well. No, I don't see any chance of SQL being outdated. Maybe like we have a revolution somewhere in the industry and some interesting thing comes over there, and after that, but right now, seeing the current structure and the things that are being working in our system, I don't see being outdated in a near future.
Very interesting question. Why is POST is not guaranteed to be idempotent?
Okay, that also depends on your use case as well. Like you can make it idempotent. Like I have created it idempotent in one of my use case in the company. Like it is totally solely on you. POST is just a sort of like, this is another concept. POST is being used in the REST framework. It is being used to create a new thing, but it is not like it is a standard. Like it is advised in the REST framework that you should always use POST to create an object, and you use put to update the object, like, or you can use patch as well. But if you consider POST, you can implement it in any way. You can also make it idempotent. Like it is totally up to you. You're getting one call, you got the answer, you get another call of the POST one. All you need to do is you need to have a certain key in your payload of the POST that can uniquely identify the record without being created in the system. So take example, I am creating my account is being created on like your university. Like I'm registering for the first time. My Amris ID is added over there. I click on POST and I click on the button of register 2 times. What will happen? My ID card will go back in the system 2 times, or I click on register once and then I click on register again. There is a possibility what I can do. I can go back in the database. If I get the result, I can return like successfully created. Like it is solely depend upon how what is your use case and how do you want to handle. You can also send, like most of the website, they say user is already created. Like that is the error they create. But when you are working in background, like I will give you example. When you post an order, okay, order is created in a system, and then it has to like in a Noon context, order is created and it has to tell a lot of different systems as well that this certain order is created. Now it has to pass the information to other system. How does it do? It does it in the background. Like it keeps the thing in the queue, and then from that queue, the system picks up and there are it's forward this information to the different system. We call things worker, like the background tasker or something. Now, when it is passing the information to other system, there is a possibility it sends the same information multiple times. So in that context, what we do, we just accept the information and we say, okay, it is successfully. We don't need to raise an error over there because this thing is in the queue and queue gets cleared when this particular task is completed. So if we send an error back to the system, it will retry after some time because it got the error last time. So it's solely depend upon which is the use case that you are trying to solve.
Okay, sir, I'll take up another 2 more questions, which is one is relevant to people wants to ask, what are the skill set knowledge that they need to acquire if they want to pursue a career into a database management system?
Okay, right now we are seeing there is a confusion that I've seen in the graduates. Like we are talking about data science, and then there is a data engineering, and then there is a software engineering. So these are all these 3 fields. You have no exemption of not knowing about database in software engineering. People usually talk about like having a strong programming skills, but that is not enough. You should also have a good knowledge about databases as well. But obviously, like when they are hiring a software engineer, they can ignore a certain thing if people don't have an in-depth knowledge about databases. But when you are talking about database field, the DBA concept is slowly going away. Like there is a very famous job that used to have in the past, that is database administrator. Now that job is being redundant and people are taking like software engineer are being like taking care of these things. Why is that? Because on clouds, all the databases are arranged over there. All you need to do is go over there, select a certain type, what is your need, how much memory you require, how many connections your system will be requiring, and you create that. So if you now want to start a career in the database, the only thing you would have to do is data engineering, or you sort of like if you included machine learning and data, or data science. So for that, what you need to do is you should know the pipelining, what are the systems require, reporting systems, because people do not want you to like write a query. They also want you to know about the concept of how to make pipelines, tableaus, showing the information, data warehousing. So these are the things you would need to know about in order to give this information.
Thank you. There are two questions which I will reframe it like this. People are asking the role, I would say, I would understand this. One is the role of database management system towards cloud computing and blockchain technology.
To be very honest, like on this topic, I don't have much information. Like I never got a chance to work in blockchain, so I would not be the right person to answer this question about that.
Okay, great. But indeed, I think cloud computing is also serving us with data as a service. Okay, DaaS. Okay, that is one of the big subjects that we have it. And what I understand internally, it does work the same way that traditional database management systems work over there, also in a distributed computing, right? Fair. I think we're done with the time, and thank you very much. I take this honor and privilege to, on behalf of School of Engineering and IT, to first of all thank Mr. Khalid for taking his precious time and giving us a very brief technical knowledge and some of the important components of database management system. It was really wonderful to have you, sir, on this session, and a very fruitful and knowledgeable information. Thank you very much for you.
Thank you for having me.
Okay. Thank you. And further, I would like to thank Dr. Pandey, or Dean and Chairperson of School of Engineering and IT, Dr. Sufia Rahman, Dr. Javed for organizing and arranging this session, and our host Darren, student of ISM. Thanks to you all, and thanks to all the participants, staff, faculty members, and other participants who have joined us to make this occasion a very technical and really a real-time database experience knowledgeable sessions. Thank you once again to all of you, and God bless you all. Thank you.